So for example 5, we have two ways of doing this. So we're going to do this in two different ways. One where we calculate a velocity and one where we calculate a distance. The first problem that we're going to attempt is the velocity problem. So for this problem, we have a kayaker that takes 4 hours to travel downstream and 5 hours to travel back upstream. So in doing so, we have two different scenarios. So why don't we just take a moment and draw what those scenarios are. But we're going to draw the scenario in terms of speed. So what I want you to imagine is we have a scenario 1 where we're taking a look at the downstream possibility, and we're taking a look for scenario 2 at looking at the upstream possibility. Now, suppose the river flows downstream this way, and then it flows downstream in the other picture as well. Okay, and we're going to call that part R for the river. Okay, and R is kind of representing the actual speed of the river. Okay, now when we talk about speed of the paddler, right, you want to imagine that when you're going downstream, it's going to be faster. So what happens is the speed of the paddler, I'm going to assume, exceeds the speed of the river. So it's going to be longer. So we're going to call this P for paddler. So what happens is there's an additive resultant for the speed that moves us down the river. Now, in order for us to move back up the river, the paddler has to exceed the speed of the river in order to be able to move back up the river. So in that case, we have this kind of weird negative addition of the paddler's speed going in the opposite direction in the second scenario when we're traveling upstream. So when you think about it, it says here that when we're going downstream, we travel 20 kilometers in 4 hours, don't we? Now, if that's the case, then the total velocity downstream, or speed downstream, is going to be, well, it's just distance over the time, which really means we have 20 kilometers divided by 4 hours, which gives us approximately 5 kilometers per hour. So let's start with that. Now, similarly, going back upstream, if it's 20 kilometers to go back upstream and it takes 5 hours to paddle, you're going to have 4 kilometers per hour, because you're going to have 20 divided by 5 in that case. And this one, the speed is going to be 5 kilometers. Now, let's start our let statements. So, we let P be the speed for the paddling in any direction in kilometers per hour, and we do the same for R being the speed of the river traveling in one specific direction. Now, when we're going down the river, basically we have an additive property for our speed. So it's kind of like you're running and wind hits your back, you end up running faster. So in this case, our speed is going to be the following. So we have for our upstream calculation, our downstream calculation, P plus R equaling 5. So we're speeding down the river with an addition of the two speeds to give us a total of 5 kilometers per hour. And then we do the same for our secondary speed going back up. So we're traveling slower, so we end up having there being a difference in speed. So when we go up the river, we're fighting against the current, so we're actually taking away from the speed of the paddle. So we have P plus R equals 5 and P minus R equals 4. For equation 1 and 2, all we're going to do is we're going to eliminate, or you could substitute. It's up to you. I just love elimination. So in this case, what we'll do is, well, 5 minus 4 is 1. That means 2R is equal to 1. When we calculate R is equal to R is equal to 1 over 2, which means R is equal to 0.5 kilometers per hour. Now, what I want you to do is I want you to now back substitute into your equation and tell me what you get. So now we sub into this, and we get the... So now, when we do our calculations, we end up with this. So we end up with our rate of speed of the river is 0.5 kilometers an hour, and our rate of speed going with the paddle is 4.5. So, and the river flows at 0.5 kilometers per hour. So there is another way to do this using distance. I'd love for you to try it, and we'll take that up tomorrow.